Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on probability, lecture number 31, in which I will solve some problems on binomial distribution. Before solving the problems on binomial distribution, we would like to remind some concepts which will help to solve the problems on binomial distributions. As we have number of trials equal to n, let probability for success in a trial equal to p and probability for failure equal to q. Therefore, p plus q equal to 1. We know probability for r successes equal to NCR p to the power r q to the power n minus r. This term is r plus 1th term of binomial expansion q plus p to the power n. Since we know that q plus p to the power n equal to nc0 q to the power n plus nc1 p q to the power n minus 1 plus nc2 p square q to the power n minus 2 plus plus NCR p to the power r q to the power n minus r plus plus NCN p to the power n. Here we see this term here. This is the r plus 1th term of this binomial expansion. Using 1 here, in 1 we see that p plus q equal to 1. So here we put p plus q equal to 1, 1 to the power n equal to 1, and right side remains same. With the help of this formula, we may find the probability distribution like probability of random variable x equal to at least 1. That is, if we are asked to find probability for random variable x equal to at least 1, then probability for random variable x equal to at least 1 equal to p probability x equal to 1 probability x equal to 2 plus probability x equal to n. For probability x equal to 1, we have here NC1 p q to the power n minus 1. Probability for x equal to 2, we get here NC2 p square q to the power n minus 1. Here in place of r we write 1, 2 and so on. And in this way we get these terms. And using 2 here, this plus this equal to 1 minus nc0 q to the power n. This is number 3. So we get two results here. Number 1, probability for r successes, that is probability for x equal to r equal to ncr p to the power r q to the power n minus r. This formula will be used to solve the problems of binomial distributions. Again, probability for x equal to at least 1 equal to 1 minus nc0 q to the power n. That is, probability for x is greater than equal to 1 equal to 1 minus nc0 q to the power n. And this result will help to solve another type of problems in binomial distribution. Now we solve a problem. Problem is a pair of dice is thrown 4 times. If getting a doublet is considered a success, find the probability of 2 successes. Now we solve this. Since when a pair of dice is thrown, number of outcomes be 36. Outcomes are ordered pair 1 1, 1 2, 1 3, 1 4 and so on lastly 6 6. So number of outcomes equal to 36. Therefore number of elements in a sample space will be 36. And doublets are ordered pairs 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. Therefore set of doublets will be a set containing ordered pair 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. Here it is assumed that getting a doublet is considered a success. Therefore probability for getting success means probability for getting a doublet. And whose probability will be? Here number of elements be 6, 6 by 36. That is 1 by 6. Let this is P. Let. Therefore probability of getting failure in a trial will be 1 minus P, means 1 minus 1 by 6, that is 5 by 6. Let this is Q. Here we have to find probability of 2 successes. Probability for 2 successes means probability for random variable x equal to 2. And we know the formula. Number of trials be 4 times. 4 C number of successes be 2, P to the power 2, Q to the power 4 minus 2. And this will be 4C2 means factorial 4 by factorial 2 factorial 4 minus 2 multiply. P is 1 by 6. 1 by 6 whole square. Q is 5 by 6. 5 by 6 whole square. Here factorial 4 means 1 multiply 2 multiply 3 multiply 4. Here factorial 2 is 1 multiply 2. And here also 1 multiply 2. Here 1 by 6 square multiply 5 square by 6 square. Here 2 2s are 4 cancel, remains 6, multiply 1 by 6 multiply 6, multiply 5 multiply 5 multiply 6 multiply 6, 1 6 cancel. This will be equal to 5 5s are 25 by 216. So our problem is solved. Now we solve the next problem. Next problem is 5 cards are drawn successively with replacement from a well shuffled deck of 52 cards. What is the probability that all 5 cards are spent? Number 1. Number 2. Only 3 cards are spades. Number 3. None is a spade. Now we solve this. Since total number cards in a deck is 52, number of spades equal to 13, probability of drawing one spade equal to 13 by 52. This is 1 by 4. Let probability for drawing one spade is assumed as success. Therefore, probability for success equal to 1 by 4. Let this is small p. Therefore, probability for failure equal to 1 minus p equal to 1 minus 1 by 4. This is 3 by 4. Let this is q. Now we solve number 1. Here all 5 cards are spade. Therefore, probability for x equal to 5. Here number of trials be 5. 5 cards are drawn successively with replacement. Therefore, this is 5c5 p to the power 5. This is 1 multiply p is 1 by 4 to the power 5. This is equal to 1 multiply 1 by 4 to the power 5. This is 1 by 4 to the power 5 is 1024. So, number 1 is solved. Now, number 2. Only 3 cards are spade. 3 successes. So, probability for x equal to 3. This is 5c3 p to the power 3 q to the power 5 minus 3 with the help of the formula for binomial distribution for 3 successes. 5c3 means factorial 5 by factorial 3 factorial 5 minus 3. P is 1 by 4 to the power 3. Q is 3 by 4 square. 5 minus 3 equal to. Here factorial 3, here factorial 5. So remains 4 multiply 5. Here factorial 2 means 2. Multiply 1 by 4 cube, here 4 square, 4 to the power 5 and 3 square means 9. Here we get 4, here 1 4 cancel. So 5 multiply 9 by 2 multiply. Here 4 to the power 4. This is 45 by 2 multiply 256. This equal to 45 by 512. Number 3. None is spade means spade 0. So probability for x equal to 0. This is 5c0 q to the power 5. 5c0 is 1, q is 3 by 4 to the power 5. 3 to the power 5 is 243 and 4 to the power 5 is 1024. Therefore, problem is solved. Now, we solve the next problem. Problem is 10 eggs are drawn successively with replacement from a lot containing 10% defective eggs. Find the probability that there is at least one defective egg. Now we solve this. Since total number of drawn eggs equal to 10, therefore total number of trials will be 10. In a trial, getting of a defective egg is treated as success. Given that probability of success, that is, in a trial, getting a defective egg and its probability will be 10%, mean 10 by 100, means 1 by 10. Let this is P, probability for success in a trial, P. Therefore, probability of failure in a trial equal to 1 minus P, that is 1 minus 1 by 10, this is 9 by 10. Now, we have to find the probability that there is at least one defective egg, that is probability for at least one defective egg. This means probability for x greater than equal to 1. And this is equal to 1 minus probability for x equal to 0. We have already told this in the beginning. And this will be 1 minus probability x equal to 0 is number of trials 10, C0, Q to the power 10. This is 1 minus 10 C0 is 1, Q is 9 by 10 to the power 10. That is 1 minus 9 to the power 10 by 10 to the power 10. This is the required result. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.